Yeah. Okay. Welcome everybody. We wait for people to connect. We have about 80 registered participants. And we see the counter is now at 20, so we wait a little bit. Yep. Now I propose that we start. There will be more people coming in, but we have quite a strict program. Welcome everybody. My name is Dick Schaap. I'm the technical coordinator from the Blue Cloud 226 project. And we would like to give you today some overview, let's say, of the work that we are doing for the data discovery and access services, and also some examples of research infrastructures that are working in the Blue Cloud and making their data available. And they will show us, let's say, the practices that they apply for making, getting the data together and say getting the data to the data discovery and access, and also working on fairness. So it's a little bit a mix of presentations. I will start with a short introduction about the Blue Cloud and also then about the program. And during the program, I will also introduce then the other speakers of today. Another thing is that we are being recorded, so we hope that you don't have any problem with this. Finally, everybody is muted for now. Later we have, after every presentation, there is a short 5 minutes for questions and answers. And then you have to stick up your hand, let's say, and then we can give you the microphone. Also, of course, you can always put questions in the chat. Okay, so let's start. See if I can find my presentation. I hope you can see it. I will put it in presentation mode. Okay.
Yes.
So I want to give you a short introduction about the Blue Cloud 226 project. Let's say, in fact, we started already with the pilot Blue Cloud project in 2019. And it was a project, a so-called flagship project for the G7, Future of the Seas and Oceans initiative. And the idea is to explore and demonstrate the potential of cloud-based open science, and then particularly in support of the health of the oceans. And therefore, we want to deploy a cyber platform with a smart federation of 3 elements. 1, data repositories, secondly, analytical tools, and thirdly, computing facilities. And in fact, using these, let's say, together, and then this way also looking at the European Open Science Cloud to set up a marine thematic EOSC, which can then serve, let's say, a wide range of applications for the blue economy, for the environment, and also for the knowledge. So let's say to do better research using the data, the tools, and supporting computing. The overall concept is looks quite simple. So it means that first of all, we have a lot of data from different resources. And the idea is, let's say, to make a common discovery and access to all these data repositories using common standards, for instance, from OGC, from ISO, from W3C, and also using a lot of vocabularies for semantic interoperability. And then on the other end, say when you have access to all this data, this enormous, let's say, pool of data, then do more with open science in a virtual research environment, and for this to develop, let's say, a platform with a lot of computing facilities and ability to build virtual labs. And that has resulted, in fact, in this pilot project. In 3 years, we've set up a so-called Blue Cloud Data Discovery and Access Service, which is a federation above many European data infrastructures. And this way we can give a common discovery and access to a lot of data. Secondly, we have set up this Blue Cloud virtual research environment, which allows you to set up and to orchestrate computing analytical services. And finally, we have set up a number of virtual labs to demonstrate that the whole concept works, so that you can use the data and also build virtual labs, which then can, let's say, help you to do analytical pipelines and help you to create better knowledge or more knowledge from the data that goes in. The project itself was very successful, and as part of the project, we also developed a so-called roadmap for what could be done in a wider sense. So we consulted a lot of stakeholders, and from this, let's say we started in early this year. We started with Blue Cloud 226 as a successor project, and in that project, in fact, what we are doing is doing further developments. And later today, I will present especially the data discovery and access service, and then I will go a little bit deeper in the optimization that we want to apply as part of this new project. This is an overview of the present consortium for Blue Cloud 226. In fact, it doubled from the pilot, and we also have partners on board from Copernicus Marine and from EMODnet, and many research institutes and many data centers. And also, what I want to show you now is the program for today. So first of all, like I say, my name is Dick Schaap. I give you a short introduction. Following my presentation, Thierry Claval from Ifremer, he will tell us more about EuroArco and the Arco system, in particular about, let's say, the data management practices. Then we have 5 minutes for question and answers. Then I will continue with explaining you another infrastructure, the CDataNet infrastructure. Then we have again 5 minutes for question and answers. And then we have Raoul from EMSO, Raoul Bajaj, and he will then tell more about EMSO. And the nice thing is that you have then, when we have done this, you have seen 3 different systems, say each of them doing data management, collecting data and bringing it together and, let's say, opening it for users. And then finally, I will do a presentation about the so-called federation, the Blue Cloud Data Discovery and Access Service, where we try to bring all those services together under one header. And then what are our plans for further optimization? So this way, I hope that's clear for you where we are going. And now I will stop my presentation. I will ask Thierry Claval to take over and present us the EuroArco system.
Let me switch my micro on. Is the presentation visible? Do you hear me correctly? Yes? So,
yes, that's fine.
So let's go. And so this is a presentation of the data management provisioned by EuroArgo ERIC and Argo Ocean Observing System. But I will just think, désactiver la notation. Okay, sorry. So I will start with a broader view. Argo is a marine research, EuroArgo is a marine research infrastructure, and ERIC. And I want to show that we do not work in silos and that the marine research infrastructure are working together. So EuroArgo, ERIC, and marine research infrastructure make continuous efforts on fair principles, fair data principles with trainings and experts. We have a yearly fair implementation profile exercise, so FIP exercise, that is a significant effort for marine research infrastructures fairness to evaluate our level of fairness and improvements. And each marine RI now have a fair data expert working with Blue Cloud community. In 2019, marine RI's data management was fair for people, but not fair for machine. This was the result of GoFair, a fair implementation GoFair project. This was also evaluated in the ANVRIFAIR project in the deliverable 9.1. So now we can say that the marine research infrastructures are significantly more fair on the EOSC and Blue Cloud. So Yes, so as an illustration, here is, I won't spend too much time on that, but every year we do an exercise to evaluate the level of fairness of our activities. It's a fair implementation profile. And in these graphics here that are published regularly, we see the yearly improvement of the fairness of the marine research infrastructure that are EMODnet, LifeWatch Marine, Argo, EuroArgo, EMSO, and ICOS. And you see that year after year, the level of fairness of our services is improving. So just one last word about fairness. Very important for us is vocabularies. This is a priority for cross-domain and integration science. So each of our research infrastructure, expose their vocabularies on vocabulary server. So before Blue Cloud, Marine ERICS did not use vocabulary server, only conventional documentation. So this meant that we were fair for humans. We would read the documentations, but now with these fair data services that we install in this environment, our eyes are becoming fair for humans and science cloud communities with the efforts we make for machine-to-machine workflow through vocabulary server. So each marine ARISE now manages its vocabulary. We perform smart mappings between the research infrastructure vocabularies, and we make an extensive use of the vocabulary server. And here is, for instance, a quick look at the NERC vocabulary server that is widely used in the marine domain. And a quick look here, you have here the list of the vocabularies and the tables, the reference tables that are managed by on this vocabulary server. And the list of the 30 blue dots here that you see here are the vocabularies. There is one square for each Argo data system vocabulary, and the other colors are from other research infrastructures, and we have smart mappings between all these vocabularies. Back to the presentation. Now I will talk about Argo itself. So what is Argo? Argo is an international program to observe the interior of the ocean with a network of profiling floats drifting in the deep ocean currents. Argo Global Data Assembly Center, the GDAC, is a data set of 5 billion in situ observation from 80,000 profiling floats. Among them, 4,000 are active, sending data in real time. And the program started 20 years ago, so it's no more a teenager, but it's getting a young adult. Argo GDAC dataset is a collection of 18,000 NetCDF files. It is a major asset for ocean and climate science and a contributor to IOCCP reports. The Argo dataset is available within one-click download. If you click on this DUI, you can get the successive images. We have monthly image snapshots and monthly imagings of the ever-growing Argo dataset. So just a quick look here. What is an Argo float? So an Argo float is a cylinder which is about 1 meter high, and that is deployed from a ship. So a research cruise ship, but also from more and more from sailing ships. So the float is deployed in the ocean. Will go at 10,000 at 1,000 meter deep, sorry, and will drift freely in the ocean. And then after 10 days, we'll go deeper, typically to 2,000 meter deep, and some of them go up to 6,000 meter deep, and we'll go up there and sampling the water column between 2,000 meter deep and the surface. And the observations, so the profiles observation, this is the vertical profiles, are sent by satellite to the Argo data system. So these are vertical profile from temperature, salinity, oxygen, pH, chlorophyll, and so on. so this data is sent to the Argo data system. And so here is a picture of the Argo data system. So it's an international program. So it relies on 11 data assembly centers, EuroArgo being one of them. And the major others are the American, the Japanese, the Canadian, 11 of them. So totally international and global ocean. And the DAX receives the data, process the data, and in continuously manner send the data to the Global Data Assembly Center. The Global Data Assembly Center distributes the Argo dataset that is continuously improved, continuously managed. And this is the GDAC, the GDAC make the data available to scientific users and to the operational community. And from there, from the GDAC, the principal investigators, the scientists in charge of Argo floats, work on the data, on the metadata, and to provide delayed mode and adjusted data, calibrated data, and send them back as delayed mode data to the DAX that will feed it back to the GDAX. And there are 5 Argo regional centers that observe basin by basin, so Arctic, Pacific, Atlantic, Indian Ocean, and South Antarctic area to check the consistency of the Argo dataset. Because as the data are produced by 11 different data centers, it is important to check that the work made by this data center is consistent. So Argo data management is performed on 3 levels. The first actor is a principal investigator. It's a scientist in charge of a series of floats. Then there is a data assembly center. There are 11 of them. They are in charge of a series of principal investigator, and the global data assembly center aggregates the data from the 11 DAX. The Argo global dataset is continuously and homogeneously managed, improved in real time and in delayed mode. So each data assembly center producing the work of a data assembly center is to produce Argo netcdf files for metadata, for vertical profile, for trajectories, and for technical data. So they work on Argo netcdf format and vocabularies, and these are published here in this document. And this document is typically updated once a year because things change, things are improved, and we are continuously improving the system, regularly improving the system. The DAC pushes the Argo netcdf files on the GDAC. So the GDAC will collect the Argo files and apply the Argo file format checker, which is a very important tool to check the consistency, the content, and the format of the files that have been transmitted by the data assembly center, and will either accept or reject the files if they are not compliant to the rules that are defined in this document, which is the Argo netcdf format and vocabulary document. And the file format checker here is available, is a software that is freely available from GitHub at this link. So, as I said, there are 11 data assembly centers. So, in detail, their role is to collect and archive real-time data, the Iridium messages received by satellite, and the Argos messages. There are more and more, and the vast majority of Argo floats are now Iridium, but we have to keep and to, from time to time, reprocess the old floats that were using the Argos transmission system. So they have to manage metadata that are published on Oceanops. The role of the DAC is also to decode, format, and apply real-time quality procedures to the data. When we say real-time QC, it's automated QC. Collect and check the delayed mode quality control data. So this is the data that will come back typically after 1 year from the observation, every year, the principal investigator in charge or the data mode operator in charge of the parameters of one float will make available to the DAX a delayed mode QC version of the dataset with better quality checks and with adjustment of the parameters compared to reference data such as CTDs performed by oceanographic cruises. The DAC then push the real-time data and the delayed mode data on the GDAC. And the role of the DAC also is to push in real time the data to the World Meteorological Organization, WMO, GTS, so the network of the operational centers as buffer built-ins. Buffer is the format used by the operational centers of the World Meteorological Organization. So all of this is documented on the Argo Data Management website. And so a picture of what we do as Argo. So what we can say is that Argo is well represented on EOSC Blue Cloud services. So I just presented you the DAC and the GDAC activity. So this is at the marine research infrastructure level activity. And in the case of Argo, it's hosting a DAC. In our case, it's EuroArgo. And the DAC is sending data to the Global Data Assembly Center. And the GDAC is a collection of netCDF files. So here I click on, this is the basic product of the GDAC, the list of that netCDF files. And so that is open and everyone can get the original Argo netCDF files. Then at the GDAC level, we manage a metadata, what I call a metadata warehouse. So we take the Argo netCDF 2 million files. There are 2 million files now, profile files of Argo. We extract them into a Spark cluster and to convert these 2 million files into 3,000 files that are Parquet file. So Parquet is a Arco format, typically efficient on cloud environment. So it's analysis ready and cloud optimized format. And so from there, we can extract all the metadata in an Elasticsearch index that will index 18,000 items, the 18,000 floats, and 10 million metadata. So each float has a vast quantity of metadata. And so here we put that available on API, and you can develop application to browse and to interactively check and look at the Argo metadata. This is the example of the Argo Float dashboard, and this is the example of the Argo EOSC future demonstrations that combine CDataNet data and Argo data. Back to the presentation. We have also a data so here it's a warehouse for metadata. We have a data warehouse. So from the same set of 2 million files, we extract the data in the same 3,000 Argo Parquet files. And from there, we take the data itself, not the metadata only, into a Cassandra database. And this Cassandra database has 150,000 metadata and 10 billion observations. And Cassandra is very efficient to make interactive queries. Interactive means an answer within less than 1 second. And so this content is served through APIs for applications such as data visualization or data selection or data subsetting. And when this is the Argo data selection tool, for instance, if I take a series of let's say 10 years of data on the Pacific, I can request this data. And so for this extraction, we'll have a subsetting of this Argo packet file that will generate either CSV or NetCDF subset of the Argo dataset, and will be made available to the user that asks them in this interactive interface. So the role, the activity, but this is back office activity, and in the Blue Cloud, the work and the issue is to develop machine-to-machine services on the data. So we developed we develop and manage a search engine, WMS and sensorsing ODC services on top of this data, the AirDAP API, a Sparkle endpoint to make semantic queries on Argo data, APIs to have efficient access to open to applications that are not specifically that are available for Blue Cloud users, metadata, vocabulary, and ontology. So these services are well documented on the EOSC marketplace. So here, these data services are used by front office application, and the first of them is the EOSC marketplace. So let's have a quick look here. I go here in the marketplace from from EOSC, and I look for Marine Argo, and we have results, a lot of results, because Argo, there are many things here, but you have to know that every day there is a publication based on Argo data or citing Argo data, a major publication or rank A publication. It's really widely used in the marine domain. This dataset is fundamental. But here, let's have a look at the services from Marine Arise, and you will see all the services that I briefly showed you here. So the Argo Marine Data Discovery, the Argo Sparkle endpoint, the Open Search API, the Float Metadata API, the Float Data API, and so on. And so these services are present here in the marketplace. I just want to mention that Argo data is also available on commercial marketplace, such as Amazon Marketplace. On top of these services, we have developed applications, a front office application. So this is the Argo data selection tool, very interactive, showing the last 10 days of Argo observation, but you can browse interactively for 10 years or more. And this is where you can query the data when you're happy with your selection of parameters, of deployment years, and so on. You can export the data you see here into CSV or NetCDF files. Here we are also very important, the dashboards that show it's not the data, it's showing the metadata. It's showing here the 3,000 active Argo floats. And if I want, I can show the full fleet, so of 18,000 floats, but I can show here the floats that have been deployed this year in 2023 by Germany, and I add the French one, and so on. And so you have something very interactive, and all the floats are showed here. And the ones that are green are entirely correct, whereas the ones that has a red light here has some alerts, and that can be further explored. So here is a picture of the data services that are available on EOSC Blue Cloud from Argo. And now to finish, the next step, we are transitioning from Argo international program to a much more wider program, which is One Argo. So One Argo is a new global design and the development towards spatial completeness to include the polar sea ice zones, the marginal seas, increase regional resolution in key areas such as the western boundary currents and equatorial region, and major new missions, the biogeochemical Argo and the deep Argo missions. So the challenges are significant new resources are needed, roughly 4 or 5 times the current investments. So we are heading toward $1 billion or euros of investments here that is needed to perform this big step toward one Argo. It requires strong community support and advocacy, and for data management, ensure that data management teams are ready and able to handle these huge new data streams and continue to grow and strengthen our national and international partnership. So in terms of data management, the Argo GDAC infrastructure that I presented was conceived 25 years ago. A significant transition towards cloud-based infrastructure is now needed, driven by the following key objective, and in particular the one Argo target: scalability to accommodate the evolving demand of Argo data management and ensure a seamless growth; reliability, enhance the trustworthiness and consistency of data operation to minimize downtime; robustness to strengthen the infrastructure resilience and capacity to withstand the challenges and disruptions. This shift to a cloud-based approach will improve the efficiency of Argo data management and align it with contemporary technological standards. And here we will benefit from the Blue Cloud activity to improve this, to make, it's not an improvement, it's really, we have to prepare for a big step toward one Argo. And here I won't have time to enter into details, but we are working on a mind map to draw all the DAC, GDAC operations of Argo and to transfer them to see the translation of these services in a cloud environment system. So
Jerry, you have to conclude now.
So I think I reached the conclusion. I will not enter into the detail of this mind map, but here is the work we are doing now to design a cloud-based system for Argo data management.
Thank you very much for this very interesting presentation. And we have now a few minutes for questions. And if you want to ask a question, please raise your hand. And then, let's say, my colleague from the help desk will give you access to the microphone. Sarita, I hope you can see hands up, because I do not.
At the moment, there are no hands up and no questions.
No hands up. Okay. So it's then it's very clear what Thierry has explained, and I admit it was very clear. If there are no questions, then we move on to the next presentation. So Thierry, can you stop sharing? Then I take over with another presentation about another system, CDataNet, that was already mentioned. Let me see if I can go full screen. Yeah. Can you see it full screen?
Yes.
Yeah. Okay. Yeah. Let's say Argo is a good example of an observation network. Say they are collecting data, while CDataNet is more a data management infrastructure. It's not collecting data itself, but it is managing and archiving and long-term stewardship for data that comes from many different sources. And that means that we have so-called national oceanographic data centers, but we also have other data centers like marine and environmental agencies and geological services and hydrographic services. And these are all data centers, and they bring together data from many different operators. And then in CDataNet, we want to harmonize the access and the discovery for this. So if you look at CDataNet, it started already in the 80s or in the 90s, let's say, with help from the Commission in the first framework programs. And over time, we had a number of what we call EU RTD projects, structural projects, to develop further the capacity of this network. And let's say, and also expanding the network over Europe, having an uptake of more and more data centers. And these are the structural projects that we have done. Since 2019, we also have a legal entity. We call it an ASPL. And in fact, what we do as CData is that we are developing and maintaining standards and also tools to serve, let's say, those standards. And we also give guidance on metadata and data formats. And also we are very active in controlled vocabularies, as also were explained by Thierry for Argo. Because what CData is doing, let's say it already started, like say, in the early days, following in fact FAIR principles before the word FAIR was even introduced. Because we are already working on standardization, having also semantic harmonization, and also following, let's say, linked web services and linked data principles. And later we adopted also the INSPIRE principles, which is let's say a directive from the Commission about I call them environmental data, to make them more harmonized. Also, what we do as part of CData, we do then also training and support to all the data centers that we have, because they have to be able to stay up to date with all the different standards that are all the time, let's say, being further progressing, and also the tools and services which are supporting the deployment of those standards. Also, what we are doing, we are very much looking at what's happening around us, let's say innovations, technologies upcoming, and therefore we have to develop the skills. And once we have developed those skills, then we have to deploy them, let's say, to the whole network, to all the data centers, so that they can take them up, and that we can in this way lift the capability of the whole network. Also, we as part of this, we also develop some common products, like a temperature and salinity climatologies. And this is very good, because if you are collecting a lot of data and you are, let's say, giving access to data, it's also good to have a feedback loop. And of course, we get a lot of feedback from users, but it's also good to use the data ourselves on a large scale, by which we also find out some of the anomalies or some of the discontinuities that we have to overcome. Finally, CData is a very important infrastructure in Europe. It works together with EMODnet and with Copernicus Marine, and also in the Blue Cloud, and also with the digital twin of the ocean. And it also works together with several of the research infrastructures, like for instance EuroArco, and like EMSO and others. And a lot of them, they adopt standards that were developed or are developed and maintained by CDataNet. And I want to illustrate this a little bit further, because what we do is, as CDataNet, we are maintaining a number of so-called European directories. These are all available as human interfaces, but also as machine, with Sparkle and SOAP services, and also with APIs. And one is, to give you an example, one is about organization. So we keep some sort of let's say a telephone book of all the organizations that they do something in this domain. Could be that they are doing cruises with research vessels. So we have a cruise summary report directory, where we keep track of all the cruises that are being taken. That is already done for decades. So we have now more than 65,000 cruises described with the PIs and the type of data they collected. We have an overview of global data sets, EDMET, which is larger data sets that are being held by about 3,000 organizations in Europe, with about the sea. And then we have another one is projects, because data are being collected in projects, and we also keep track of projects, so that so we can make that link. And finally, we also have done an observation set, ADIOS, where we keep monitoring programs and also metadata on the, let's say, all the stations in those monitoring programs. And then we have, as a core service, we have the so-called CDI, the Common Data Index, and we give discovery and access to data. And this whole network, let's say, by all our national nodes, they maintain this network, and it's fully working in a linked data principle. So you can hop from one point to another point. So you can look up an organization, see what projects were they involved, what cruises have they undertaken, what kind of data do they have. But also in this way, we are able to mark up all the metadata in a fair way, giving a lot of information about, let's say, all these different components which are relevant to qualify and to describe data sets in a fair way. Like I said, we have these standards, so we maintain those for metadata formats and also for data formats. And I see that we have two standard formats. One is the ODV ASCII, and also we have NetCDF. They are all both fully controlled or fully supported by controlled vocabularies. And those vocabularies, we have now more than 90,000 terms in more than 110 lists, which are also used on a global scale. Let's say many international organizations are using them. And also we have mappings with other existing vocabularies. And again, everything is fair, findable, accessible, interoperable, reusable for machines and for people. And we work closely together also on a global scale with IOC and with ISIS to make sure that the quality control procedures, etc., that we are really tuned together. This is our core data service, CDI Data Discovery and Access. And over time, let's say we went from let's call it local PCs and local computers, let's say, to a more centralized system with a cloud. And that was done in the last project, the CData Cloud project, where we work together with UDAT, which is an organization of academic computing centers in Europe. And in fact, what we have is we have all these individual data centers. They take in data from various sources. They do quality control. They do formatting. And from there, let's say they share the metadata in a common catalog, the CDI catalog. And they also share the open data in the cloud data cache. And that's something that we did in this project. We built that part of the architecture, because in the early stage, we only had a metadata catalog. And then if somebody ordered data, let's say they had to wait for the delivery of the data from the individual data centers. Well, now we have this, let's call it this cache in between, so that the data can immediately be delivered when it's open, because we also have some restricted data sets, about 5%, and that's more for seismic and for bathymetry. And then you have to do a request and then see if your request is being honored by the data originator. To tell you a little bit more about this system, we have quite a coverage. We have now, today, let's say we have more than 2.9 entries for physics, for chemistry, for biology, geology, bathymetry, and geophysics. And there are 117 data centers who are responsible for this data. And they are located around the European seas, and they bring together data from more than 970 data originators. So it could be universities, could be other research institutes who bring their data to these, let's say, these aggregation data centers, and from there it's being set up, made available in a common way, with common meta and with common data set formats. This is the interface, let's say the human interface, but we also have APIs. We have Sparkle to be able to serve the data in machine-to-machine interactions. Also, we did a very strong cooperation with EMODnet, and that cooperation already started, let's say, at the beginning from EMODnet. In fact, it helped EMODnet to develop in a very fast way. And because we already had a lot of data, while in EMODnet we are focusing on making products and services for which you, of course, need a lot of data. And like I said, CData qualified from the start as a leading infrastructure for several of the components of EMODnet, because EMODnet is looking at different thematics, bathymetry, geology, biology, physics, seabed habitat, chemistry, human activities, and there's also an ingestion portal. And since the beginning, let's say, we became, let's say, the supporting one of the major supporting infrastructures to connect the data from the originators towards EMODnet. And in EMODnet, there are groups who then take the data and they develop them products, like, for instance, a digital terrain model for Europe, or collections of eutrophication data sets, which go to the Marine Strategy Framework Directive community. Here you see that something that happened quite recently. Before EMODnet had thematic portals, but now we have one central portal where all the thematics are brought together. It's here you see also the URL. It's a very nice portal for you to visit, because it has a lot of products and it has a lot of services. And it's in fact it's a marine in situ data portal. It's driven by DG Mare, so it's a top-down initiative. You can compare it, let's say, the brother or the sister is the Copernicus Marine portal, which is a comparable initiative, also driven by the Commission. But this is only possible because we have all these research infrastructures and all these people that are collecting data to push their data into the, let's say, these infrastructures and make products and services and forecasts based on that. If we look at this, CData is in this way feeding several of the thematics. It's the major data service for bathymetry and for chemistry. It's also contributing to physics. It's also contributing to geology and also to biology. So you see that in this way, let's say the data that are being collected are also being used on a wide scale in EMODnet. And this is some example for bathymetry. Bathymetry develops the best digital terrain model for European seas at a resolution for 150 meter by 150 meter. And that's based upon more than 17,000 survey data sets. And all those survey data sets, they are described in the CDI system. So you look on the right, you see a source reference map, this mosaic. Every cell is in fact shows which data set was used to deploy that part of the DTM of the digital terrain model. You can click on it and then you get in fact the CDI metadata for that data set. And on the lower half of the picture, you see, let's say, all the track lines of those survey track lines, which are again from the CDI system. So we have about now 40,000 bathymetry surveys in that system. And from those, 70,000 were selected to be part of that jigsaw puzzle to build the digital terrain model. And this is refreshed every 2 years. So all the time more data comes in, but then every 2 years, a new digital terrain model is being released. Okay, now a little bit more in the details. Let's say we have this CDI metadata format. It's a profile, a marine profile of the ISO 19115 standard. It follows it's so-called Inspire compliant. We also, for this, let's say we use the ISO 19139 schema, and we have all kinds of documents, let's say, for describing this profile with all the different meta tags and also how the meta tags are being filled and how you express them in XML. Then it's being supported by controlled vocabularies and also by these European directories. And this way, almost all the text in or the terms, let's say, in the metadata profile are being filled with controlled terms. And that, of course, is very, that gives you consistency. It gives you also much better semantic interoperability because other systems, they machine to machine can talk to each other because they recognize the terms, the codes. And it also allows, let's say, to get a very, I would say, harmonized and homogeneous catalog for all these data sets. And we have millions of them and more are coming in. Also over time, we have, like I said, we have two basic formats, CDataNet ODV, ASCII, and we also use NetCDF, CDataNet profile, where we have a dedicated header with CDataNet metadata. They are linked to the CDI because the CDI contains more of the metadata. So together, say, they give you the full picture. But over time, we had to develop, let's say, variations on the data format for different types of data sets. So we have for physical, it was developed with the NODCs, but for chemistry, we did a lot on eutrophication, contaminants, and also on marine litter. And for that, we developed some new formats, let's say, based on the ODV. And the NetCDF, we have also for biology a special one, which was developed with Eurobus, etc., etc. So you see that we are working together with different communities, different leading communities to give feedback on the formats that they're using and what kind of specific elements they need to make the data more fit for their purpose, and also in fact to make it more fair for other people that want to use it later. And then those controlled vocabularies, of course, they are very important. And every time these vocabularies, they grow, because if we work with marine litter, we had to introduce a lot of new vocabularies, especially to describe the marine litter. And that was done, of course, not in isolation, but always in working together with the let's say, authorities or communities that already have done a lot of work in that sense. Let's see, I have 5 minutes left, so I want to tell you something about the architecture. What we have right now is we have 3 components. First of all, we have a data center. So we have more than 110. And they are locally, they do their local data management. So they get the data in. And then as part of the CDataNet cooperation, they also make the data fit for sharing with metadata, CDI format, and the data in the CDataNet formats. And therefore, there is a so-called replication manager. That's a node they can install that can talk machine to machine with the CDI import manager, a desk that we have in the central place. And that import manager also talks, let's say, in the replication manager with the cloud, where we in the end store the data. So the metadata goes upwards to the central, let's say, CDI database and to the dashboards, while the data itself is being stored in the UDAT cloud. And then later, let's say, if somebody is interested in data, they can find the data in the user interfaces and on the top. and then do a shopping request, and the shopping request then is translated into retrieving the data from the cloud and retrieving the metadata from the CDI database and then delivering that to the user. So it's quite a system, and that so it's the latest evolution that we did. And of course, we are always working on improving, enriching metadata further, but also improving the services, because over time, data services also, let's say, they have to be replaced by new developments. And as part of the Blue Cloud, we are right now busy, let's say, to further develop, let's say, the UDAT part, because there are some new technologies that we want to use now. If we look at the local data center, to be able to join this work, we have some tools, offline tools. One is Mikado, is an editor for XML. We have Nemo, which is more for preparing data to the CDNet formats. And also we have Octopus, which is also a tool, let's say, to check the format of the data sets, the format, and also to handle what we call multi-files, because sometimes people, they put data from a lot of, let's say, a lot of observations in one big file, and Octopus helps you to be able to handle that. And then we have two ways, let's say, to prepare. It could be manual, but of course it's not advised, only for the first time. But then it's better to couple it, let's say, to a database, your internal database, do a one-time mapping, both to the format as well as to the vocabularies that we are using, because you have to look at your range of terms that you use, how they fit to the different vocabularies. And from that point on, you can then push the button and you compare your data. And that looks a little bit like this. You have a flow. Let's say first the manual example, you have some files, data files. You use Nemo. The Nemo takes care that you generate the CDNet format. Then you have a QC activity, let's say using Octopus to check that everything is okay. And then we also have a local metadatabase, and together that generates, let's say, and using the vocabularies, that generates the CDI metadata, and that generates the data files. And then we have a coupling table, which tells you the relation between the metadata and the data files. And those goes to the replication manager. And from there, there's the import manager that makes sure that the data is added to the CDI and to the data catalog, the data cloud. And this is all, let's say, the import manager. All these are all tools, like a dashboard that data centers can manage. There's another one which is more used, is that the data center has a local database with metadata and data. They do again the mapping, and they use the tools, let's say, and not any manual, but it all goes in an automatic process, because they have a one-time setup, one-time mapping setup, and from that point on, they are really every month they send new data forward, which is then being added to the catalog system. So conclusions, I want to say that CDNet is a very important standard setting organization. And also those standards are widely adopted, and you find them everywhere in the marine data landscape. We have a very large network of data centers that's still expanding, because as part of the EMODnet activities, let's say, we have uptake by new data centers that also want to join the action and bring their data in. We have almost 1,000 data originators right now, and that's also growing. The network itself takes care of long-term stewardship. So if you have interesting data sets, let's say, bring them to your national data center, and from there on, let's say, it can be added to CDNet. Also, these collections that we have are input for many derived products, especially in the EMODnet and Copernicus, but also now in the Blue Cloud, we make full use of those data collections for virtual research. And finally, CDNet is always continuing to underway, let's say, with innovating its standards, looking at the latest state of the art, and looking at what people need, listening to users, and also this is done by participating in many EU projects, which allow us to do innovation and maintenance. Thank you for this presentation. We have now some time for a few questions. I'm right on schedule, by the way. We have it's 5 to 11. Are there any questions? Is it all clear? Are you a little bit overwhelmed by all these enormous systems that you never knew that there was so much behind? Because that's also with Argo. It looks quite simple. You say you collect some data, and from that moment on, you have access to the data. But of course, there is quite a lot, let's say, behind to be able to get homogeneous, high quality output. And also in an organizational sense, we have many players, and these players all have to play according to the same, let's say, the same playbook. That's also takes quite some efforts. to develop this. There are in the chat. Let's see if there's a question.
Not really. I think you were quite clear, Dick.
Yeah, no question. Okay. Okay, then we continue the program. So I want to invite now Raoul to tell us more about the EMSO, which is another research infrastructure, and to see how they are, how they do it. Let's say, what are their practices, and also inform us, of course, more about what EMSO is. Raoul, can you take over?
Okay, hello. Thank you very much. I'm going to share the screen. Okay, thank you very much. So I prepared the presentation, this webinar, thinking of what of all the things that we have can be useful for you if you want to make something like a data management system, and thinking of you can use of our system. Okay, so in this case, the objective of this part of the webinar is understanding what is EMSO and understanding why we are using these strategies for the data access and the data harmonization, how we send the data to all the other projects, for example, to Blue Cloud. I'm going to provide you the tools for the harmonization system that we have, and here I'm going to talk about some tips and technical details if you want to use it. And then I'm going to show you how to use these tools with practical applications, strategies in action. And at the end, please, if you have any question, I'm happy to answer all that you want. So first of all, let's say what is EMSO. EMSO means European Multidisciplinary Seafloor and Water Column Observatory. It's a research infrastructure center that contains 27 European institutions and 14 sites. In the sites we have observatories, and the observatories can be buoys with sensors to measure the water column. And then we have other type of sensors in the seafloor. And we also have in some research infrastructures, we have gliders, AOVs, or drones. The typical activities that we do in EMSO are the participation in research projects, and we are providing the physical access to researchers or to technicians to the research infrastructures to there check the sensors that you have. So you can use these research infrastructures to test sites for new sensors or new systems, whatever. And we are also providing the data access of all the data that is involved to all these type of ERIC and all the sites that we have. And now let's talk about the important part of this webinar, that is the data access strategies that we have. So we did two approaches in EMSO ERIC. We had an initial approach that was to make something very centralized, data infrastructure in the central management offices with a centralized harmonization system. And then around 2022, we decided to change this approach to something more decentralized, with a decentralized data infrastructure using ERDAP. Okay, I'm going to talk about ERDAP and the tools that we are using now. Let's start with the initial approach. When we started EMSO, we had something like this. We started to talk with all the institutions and all the research infrastructures that were part of EMSO, and everybody of them were providing data following the FAIR principles and in a good way. It's true. It was a way following the best practices and everything. But the FAIR principles and the best practices doesn't mean that data is the same. Of course, maybe if one research center is using one vocabulary and another is using another, finally, you need to do something to match this data, of course. So at that moment, that it was a long time ago, we decided to talk with them. And at that moment, the research infrastructure, some of them, maybe they couldn't make the change to make something more harmonized because maybe they didn't have enough resources, people to make this change, or they didn't have time because they were working for another projects and they didn't have time to change all the system that they had to publish the data. So internally at EMSO Central Management Office, we decided to create a technology to collect all this type of data that sometimes can be different APIs, sometimes can be raw data, or sometimes can be another type of formats, just accessing to the database that where the research infrastructures had the data. So the idea is to make this technology to collect all this data, and then when you have all this data, always create the same protocols to then publish the data curated. So for example, always pass the same quality controls test, always make the same things, the same correlations, everything. And then when you have your cleaned data, let's say something like this, then you save this data in another database, and the final user can access to this database or can go to the databases or the different access methods of the research centers. And everybody was happy like this. So we create Muda. I think that some of you, I see in the chat, yes. I know that some of you were using Muda. Muda means Module of Onshore Observatory Data Analysis, and is a Python package, and is quite easy to use because it contains a lot of documentation and a lot of examples. So the idea is that you don't care about the data source, the format, etc., because everything is translated to an internal format that is water frame. And when you have everything in a water frame, you start to work. You can create quality control test. You have specific functions for quality control to make plots, interactive plots that are quite nice. And then when you have everything finished with your data set, then you have specific functions to reingest to another databases. For example, we have specific functions to ingest to an Elasticsearch database, okay? So if you want to check Muda, this is the information that you need. You need to install PyPy, install Muda, or go to the GitHub. But I have to say that we didn't work with Muda since 1 year and a half, and maybe some of the dependencies that are in Muda maybe are decrypted. I don't know. I have to check it, okay? But why our initial strategy was changed? The reason that at some point, at the beginning of EMSO, everything was quite easy because we had only a few data sources. Let's say data sources, so different types of data sets, okay? But then these data sources were increasing all the time. And finally, with the Muda, you need to prepare a script for each type of data sources. And around the 2022 was very difficult for us to continue this way because it takes a lot of work. Even in a research infrastructure, for example, they had different data sources, different type. For example, if they are sending us raw data, each sensor that they have need a specific script to manipulate all that information. And this is a lot of work for the limited human resources that we have at EMSO. The IT group is quite small, and we have to make a lot of things, for example, develop European projects, not only this. So we decided to change the strategy because this was not useful at around 22 to now. We had there a lot of work. So we decided to make this second approach, that is everything decentralized. In that occasion, the infrastructures were happy because maybe they had different projects, something like this, to make a new system to send the data, to have the data access. So we decided to use ERDAP. I think that some of you know ERDAP, others no. Okay, ERDAP is something like a software that you have all in. So it's a pack. You have there a user interface, you can put there some files, and then it creates a web page for you, and it helps you to download data and all these kind of things. It's very easy to use. It's quite difficult to configure initially, but when you have everything there, it's okay. It's great. And the good thing of ERDAP is that you can create a federation of ERDAP. So if you have different centers, imagine centers, different, I don't know. In our case, research centers, each research center can be the curator and the owner of the ERDAP, and then you can create whatever you want, a single point of access to all your network of ERDAPs. So for us was quite good. As I said before, you have a user interface, you have a RESTful API, allows the federation of ERDAP, and another good thing is that it accepts a lot of formats of files. So if you have a data file, your raw data is in CSV, is okay. If it's in NetCDF, is okay. If you want to connect to an SQL database, is also okay. You just need to configure the ERDAP and nothing more. And here, this is a very important part for you, I think. This is the useful part also. Because I'm providing three links to the tools that we are using every day at EMSO. The first one is the ERDAP Playground. That it contains a very simple tutorial to install this ERDAP in your computer if you want to try it and to test it. I think it's the easiest tutorial that I have never read, because only in 3 lines of command line and using Docker, you will have this ERDAP in your computer. So it's very useful. Then the third link is the EMSO metadata specification that is also on GitHub, and like Dick and Thierry told, we also have this metadata specification somewhere. In our case, we have the metadata specification on GitHub. You can check it there. Our metadata specification is also based in a lot of standards that all the other infrastructures are using. So it's based on the standards that CDataNet and Argo is using, right? But maybe sometimes we use some parameters that are quite different. For example, the EMSO code, something like this. Okay, everything of what we are using in our standard is here. And then the second link is the metadata harmonizer. That is something similar like the harmonizer tool that was using in Argo. That is, in this case, is in Python and is quite easy to use. And the typical thing is that you connect, you program this tool to connect to an ERDAP, and then this tool is going to check if all the datasets of your ERDAP are compliant with a metadata specification. In this case, the EMSO metadata specification. But if you want to use this metadata harmonizer for another project, it also can be possible. Just go here, fork the code, and change the metadata specification. We have linked the metadata specification to our metadata specification, but you can change it, okay, if you want. And of course, we have other services that, in this case, as I said before, maybe are not very important for you, because are the typical things that a lot of infrastructure has. For example, the PID, the file explorer, that is a way to view the data in like a catalog. We have Jupyter Labs. We are doing derived products, dashboards. For example, we are doing plots like this that are quite nice. The ERDAP provides you a way to create this type of plots, but not like this. They are quite ugly. If you want to make a web application, something like this, you need something more. because the plots that are doing with ERDAP are static, for example, and maybe it doesn't fit with a website. You need something more. And the big problem of ERDAP is that ERDAP is really slow. I mean, depending on what you are asking to ERDAP, maybe it takes 5 minutes or 6 minutes to get the answer. For example, if you want a data set of water temperature of 10 years of one site, maybe, yeah, you will have the answer in 5, 6, or 7 minutes. And this is crazy. This cannot be possible. And this cannot work like this if you want to make our website application, because the user is going to think that your application is break, for sure. So this is a tip. What we do at EMSO using ERDAP is, for example, a user that requests for a plot using the web application, the plotting tool. What we do is the data portal is connected to the internal API. And then the internal API, what we do first is check if we have the plot in memory. If another user asked before you the plot that you are asking. If you don't have this plot in memory, then you check if you have the data in memory, okay? If you don't have the data, the third step is you ask or you request the data to the ERDAP. So then you create, you save this data in memory, you create the plot, you save this plot in memory, and then you send the final result. So if you are a user of the EMSO data portal, you have 3 options. If you are requesting for a plot, maybe sometimes the plot, if it's very simple and very common and very popular, for example, temperature of the water, that is something that everybody just for curiosity is looking for, you are going to have the answer very fast. But maybe if you want something very specific of your project and this stuff, okay. I don't know how to say, but maybe you need to take a coffee before you get the answer, okay? Yeah, it's like this. So my concluding thoughts are that I think that the initial approach was quite good. And if you have enough resources to make something more centralized, even if you have different other different ways to access different data, it's okay. But if you can control as much as you want the harmonized system, it's quite useful. Then it's easier, for example, to create new products. Then it's easier to connect your platform because you are the owner of the platform or you are the builder of the platform with another initiatives. So you have more control and it's easy. But sometimes it doesn't work because it's very costly in terms of people. You need a person who need a lot of effort doing like this. And sometimes, yeah, this is useful for small projects or maybe for small companies, or if the data sources are quite similar, okay? Adopting the second version, the actual version, is okay for us. And using a wrap, if you want to test it, is very simple. So is a good option. But remember that then if you want to make derivative products, you will need also to create a layer, a higher layer to interact with the ERDAP, because ERDAP is not enough to make all the interactive plots and all the interactive parts that you need for a website. So the ERDAP has some limitations and you need additional layers. Thank you very much. And I don't know if I have time. If I don't have time, I stop here. And if I have time, if you want, I can share more.
Raoul, you still have 6 minutes.
6 minutes, excellent.
Yeah, so you have some time.
So let me show. Okay, this is the GitHub of EMSO, I'm going to start showing some particular things of Muda if you want to try it, to test it. Here you have the documentation, okay? The API reference include all the information of all the functionalities that you have in Muda. And then you have some examples. This one I think that is quite useful. That is, for example, here you have a signal like this, that in this case is water temperature, for example. And then after you pass some quality control test, you filter all the noise and all the bad values, and then you receive the signal with only the correct values, okay? Then this is the ERDA playground, okay? For install the ERDA playground is quite simple. This documentation is done by ENOC from the UPC, this part of EMSO. And all that you need is to install the Docker and the Docker Compose, okay? And then you just need 3 lines of code. And after these 3 lines of code, the Docker is running in your local host. Is great. I think it's great. It's fantastic. But the problem is that the ERDAP, then the configuration, the internal configuration, it will take you a while to configure everything, okay? But because it depends on the data set that you are putting, okay? So in the internal configuration, you need to clarify if you want to use a CSV, another type of data set, etc. So, but the initial installation is very simple. Then here, the metadata specification is also graded by ENOC. Here, it contains all the metadata specification with all the names that we are using in all our datasets that we are using in ERDAP, okay? So if you have any question or you want to know what means a single value, a single name of this dataset, here you have everything, and I think it's quite easy to understand, at least in my opinion. You just need to find here the parameter and look for what it is. So it's very simple. And then the final one, let me see, the metadata harmonizer. Yeah. As you can see here, is a Python tool. This is the tool that checks if the data that you have in ERDAP is complying with a specification, okay? So it's quite easy because you just need to, let's say, clone and install the requirements. And then here, you have to add the URL of your ERDAP and say which dataset you want to check and nothing more. Yeah, and it will tell you how much compliant is with the specification that you choose, that in our case is EMSO, the EMSO specification. Okay. And nothing more. I don't have anything more to say, so thank you very much. And now, yes, please, if you have any question, I'm here to answer. And don't be shy or scared, because I'm more scared than you.
Okay, Raoul, thank you very much. Indeed, we have now 5 minutes for some questions, if there are questions. So please raise your hand if you want to ask something.
There were some questions in the chat, but they were already replied by Thierry.
Okay, okay. Okay.
Namely for EMSO, for Raoul.
Here, Raoul, very nice looking plots you are made on top of ERDAP. Can you share the code base to use to create? Sure. Yes. Column roller, yeah. the code base is not here, is not in the links that we are using, because are based on is the internal API that we are using. But of course, if you want to see how we are doing this, it's quite simple. I can show you some examples with a script that we have an easy way to connect to an airdrop, and then we are using the library that is called Plotly, that is very popular, to make these interactive plots. Okay, so sure, if you want, contact me later on, and I can send you an example.
Are there more questions, Ro, or no? That you can see? No?
I don't see anything.
Okay. Okay. Now then I take over again and say I go to the last presentation, which is about what we are doing, in fact, in the Blue Cloud for the Federated Data Discovery and Access. And you've seen now, let's say, several of the systems, and you see that they all have, let's say they have the same philosophy, of course, but at the same time, let's say they have a different technological and different content deployment. And what we do in the Blue Cloud is in fact building a federated discovery and access over all those services, those machine-to-machine services. And also we want to make that more fair, let's say, and more harmonized. And then that's a little bit the challenge that we have. So, and what you also see, of course, from the presentation so far is that all the infrastructures today we gave you 3, but we have more in the European data landscape. They all are all the time innovating and further evolving their services, because there are new technologies, but there are also new requests and new requirements, and that's an ongoing task. And that happens also in semantics. Let's say more and more semantics are being adopted, and this way also taking care that the machines speak in a semantic way the same language with codes, which then can be translated, of course, in many countries, in many languages, because that the code is the same, but we can go from Spanish to English to French, etc. if we simply have a code with the translation. But I want to show you, let's say, how this works. So let's go here. First of all, just a picture. Let's say that there are many ways to collect data. And there are also many infrastructures, let's say, that are part of the Blue Cloud, which work with us. And each of them, let's say, they are or an observation system, or they are more a data aggregator. They bring the data together. And also in several cases, let's say, they do then analyses and further quality control and harmonization, etc., to make the data more fit for use by others. And in the pilot project, we already set up this Blue Cloud Data Discovery and Access service. And in fact, we federated the infrastructures that you see in the top bar. So some elements from, let's say, services from EMODnet. We have EuroArgo, we have EcoTaxa, which is more microscopic images from biotaxa. We have CDataNet, I explained to you. We have ENA, which is DNA sequencing. We have Eurobus, which is more about biodiversity. We have SOCAT, which is more about carbon atlas. And we have EOSC Marine, which is also carbon data. And in fact, if you look at all these systems together, let's say they have more than 10 million data sets. And as part of the Blue Cloud itself, we are expanding this service, to say, with four new ones. One is EMSO, but also EOSC Physics will come along. Also, we have Magnify comes along, which is again with more with genomics. And finally, also CEOS will come along. But CEOS is more with as an Arctic observation system and information system. Now, what we want to do with the discovery service in Blue Cloud is a federation, and in fact, to have a federated search that people can find interesting data sets. First of all, they have to be able to find which of those infrastructures behind are holding those kind of data sets, and secondly, then they can drill down to retrieve actually the data, and that can be done then with a generic shopping basket which runs on top of this. It's also interesting for the Blue Data infrastructures themselves. Let's say we call them Blue Data infrastructures. That's our for definition. It's also interesting for them because, of course, they can reach out to more users. It's also something that we are connected to the EOSC, the European Open Science Cloud Marketplace, so you can find the service there. And this way you can reach out to other people that are not so well aware about what all these infrastructures have to offer. And this way, of course, we are also working together and learning from each other about how to make the services more fair, how to have an uptake of new technologies. And that's also something, like I said, is part of the lifeline of all these facilities. You have to stay up to date and state of the art to be able to serve in a changing environment where more and more data becomes available with new sensors, with new laboratories, and also where more and more users are having certain requirements. So we have here an illustration of the types of data that we manage. So yeah, it's just an illustration, but you see it's quite different in types and in coverage, and also in scale. Then we developed this two-step approach. First, we said, let's look at the sort of data collection level. And that collection level is then to identify which of the research infrastructures, let's say, has interesting data sets. And then the second step is that once you have found, then you go deeper with additional criteria. In fact, you're going to search for the granular level, and then you really are drilling down to the actual data. Give you a good example is what we saw from the Argo. Argo has about, say, over time, they have about 18,000 Argo floats. For us, that's the data collection level. So these floats, because these floats, they make different dives or different cycles. And over time, say these 80,000 have collected more than about 3 million cycles, data sets. But by using, let's say, then the float as the collection level, and then the cycles at the granular level, let's say we are able to use this concept for Argo. Sometimes we cannot do it in two steps because we have sometimes we have services that have already data collections. They have products and they don't go to granular, but because the collection is something that you can download as a whole. In those cases, let's say we stay one-to-one, but in a lot of cases we try to go from one to many, let's say. Also, everything has to work with machine-to-machine services because we don't want manual intervention, because the manual intervention already takes place at the data centers and at the research infrastructures, but we don't want it in this discovery service. And also there is let's say every week there's an update of the whole content. So then there's a reharvesting and retuning with the machine services to be able to stay close to what is being offered at each of the individual Blue data infrastructures. This is the architecture. I don't want to go too deep in it, but you can say we have a couple of things. We have the individual services, the Blue data infrastructures. They have web services and APIs. And then we have a Blue Cloud metadata broker. We have a data broker, and we have a so-called data cache, which is for temporarily storing the data that we retrieve following a request from users. And then we deliver, let's say, the basket to the user. And we can also push the basket into the virtual research environment, which is another part of the Blue Cloud platform. And if you have an example, this is, let's say, we do here Argo. So we have here the home page of the Data Discovery and Access. we search for a certain with a number of universal criteria, like when, where, what, and this way, let's say, we get some results at collection level. And then this is the case we took Argo, and then we see, let's say, these are the collection of Argo. So in fact, the areas where the cycles were taken by individual Argo floats. And then we can go to level 2, we drill down, and then we get the individual cycles. So we have some more fields, let's say, for searching on the left. And we are now, instead of being generic, we are now choose the Argo to go deeper. And then we can see the individual, let's say, cycles from this Argo float. And then you can, let's say, put these in a shopping basket and get it delivered in a common way by the cloud system, which is the delivery mechanism. For this, we have at level 1, we use so-called DAP service. The DAP service is what it does. It's in fact an OGC service with the CSW protocol, catalog service for the web, and it has plugins to translate the metadata at that level, at that collection level, from each of the individual Blue data infrastructures to a common format, a common metadata format. And on the left, you see the common profile, which is in fact an extraction. So it's again the what, the where, the when, the parameters, who, and also, if possible, the platform and the instrument. and some, let's say, some keywords in an abstract. And this way, let's say, we can make a common collection of collections by using this DAP at level 1 at collection level. And right now we have about 25,000 collection entries, and those 25,000 are also shared with the EOS. Let's say they're synchronized with the EOS catalog, so that EOS people can also find them. And if they want to know more, say they're coming back to the Blue Cloud servers to be able to drill down to the second level. For the second level, we use various web services from the individual providers. And you see the type. So we have, in the case of CData, the CDI, we have a dedicated API for the CDI data. For the products, we have CSW. For chemistry, we also have products, CSW. EuroArgo, we use a dedicated API, as was explained by Thierry. For Eurobus, we use at this moment a DCAT service, but we are going to change to an OAI PMH service. For Ecotaxa, we have a dedicated API. For Elixir ENA, also a dedicated API. And for ICOS, we use a Sparkle service. And for SOCAT, we use an AirDAP service. So you see there's quite some different machine-to-machine services, let's say, that are being used. And the key is a little bit, let's say, to make use of them and to see how rich they are in functionality, but also in of course in provision of metadata that we need, and then in the end have to lead to the data itself, which should be connected. And sometimes it's a little bit a puzzle, but it's also part of the Blue Cloud project, let's say, to where we find some inconsistencies, or let's say we ask for improvements to be able to get a more smooth and streamlined operation. And that means that at that moment, the Blue Data infrastructure itself has to do something in their service, say, to follow our requirements. At the same time, of course, then taking care that they make their own service also more fit for the purpose, the general purpose, because they don't only do it for Blue Cloud, but they do it also for themselves, because they also have their own portal and various services and further other users. As part of the Blue Cloud, let's say 226, so this first system that's working, but we said we want to harmonize a little bit more the functionality and expanding the functionality of the web services at each BDI. Also, we would like to bring in semantic brokering, because so far we give you the terms, but we are not doing the brokering. So we are not harmonizing the semantics, but we can do that by adding also a semantic brokering part. We want to expand by having 4 more Blue Data infrastructure, like I said, EMSO, CEOS, EMODnet Physics, and Elixir Magnify. Also, we would like to know something else, is that what we see so far, it's like a little bit like angling. Say we have a discovery mechanism, which has a metadata record, and the metadata record, let's say, then corresponds to a data set. But sometimes such a data set can be quite large. And also it's not always what somebody wants, because if somebody asks for, let's say, 1,000 data sets, then they have to do a lot of work themselves to extract maybe the thing that they want. And what we see is that also people would like to see, in addition to this angling, following the line, they would like to see subsetting. That they say, I want to have all the data for temperature from all the different repositories, but then let's say at 500 meter depth, and only for a certain year. And then you take not the data files anymore, but you want to extract data from all those files and deliver one dedicated file, more or less. So for this, let's say we're also developing technology, and we also want to expand, say, the data discovery and access service with this kind of technology. In fact, something that Raoul was describing a little bit with AirDAP. Say AirDAP is too slow for big data, so you need something underneath, let's say an engine, that helps you then to extract the data, which then AirDAP can easily transport and communicate to the user. And then you have an engine, say, for the, let's call it big data crunching, and you have another engine which is very good in communication and transforming data sets to other formats. And this last thing is a little bit, this technology is building data lakes, and data lakes will become very important also for the digital twin of the ocean developments, where they want specific data sets on a regular basis to be delivered, high quality data sets, authorized data sets, which then can be used, let's say, to run the processes in the digital twin of the ocean. Therefore, in Blue Cloud, we have a couple of requests to our colleagues. In fact, one is that they express their vocabularies in a more explicit. And for this, let's say, in fact, because right now, for most of the servers, we get terms like sea level, but we also would like to see, while they are using internally, let's say they're using coding from certain vocabularies. And therefore, we would like to have these triples also in the output that they provide through their web services. So that you have the term, but you also have the code from let's say the identifier of the code, and thirdly also the vocabulary that's being used, let's say, to serve that code, because then we can resolve, let's say, working with codes, and then we can also add that later into our semantic brokering to be able to harmonize the output of variables or platform names or sea areas or instruments or you name it into a common approach. Also, we ask all the Blue data infrastructures to check where they are using vocabularies, and if they're not using vocabularies yet, let's say to adopt in fact some standards, the CDataNet standards, which is the BLC, the CDataNet controlled vocabularies, which is very rich. We also have this ETMO for organization codes, because organizations play a big role in collecting data, in managing data, in distributing data, and also for reference referral, and also maybe the projects and the crew summary reports, and also worms, let's say, for taxonomy. So there are many. We asked then our colleagues, let's say, to check effect and to adopt, to make their metadata more rich and also more harmonized, or provide us their vocabularies by which we can do a mapping between them using the semantic broker. Also, in some cases, we asked the BDIs to improve their web services, because we have we saw some issues there, and we are then discussing that with them to how improve. And then we have on the central level, let's say, our colleagues CNR EAI, that they are doing the DAP broker, and they want to include then those semantic triples into their output also. As Maris, we will work further on this level 2 broker, that we also include the semantic triples in our search and output. And finally, BDC will work on this semantic analyzer and the semantic brokerage, so that in the end we have a more harmonized metadata using common semantics. What we also will do is, right now we are using Marine ID as our AAI for the data discovery access, because you need to be registered to be able to launch your shopping basket and to retrieve your shopping basket, because there's a sort of dashboard with a sales ledger in it. And we want to change that now, say, to using the same system as being used in the Blue Cloud for the virtual research environment, and which can also then federate with the EGI check-in, so that everybody who has already a login from a university or from a research institute, that they can simply use the same credentials, let's say, to walk through the system and make their shopping. We also want to do some federated monitoring, but I'll leave it here. But what's more important is that we are also looking into this subsetting, because the subsetting is quite a challenge, and it's something. It's a little bit the holy grail, I would say, for for a lot of people that enter in with big data sets, and that's happening more and more. We have a lot of observation systems, and the number of data sets and the length of the volumes, let's say, are increasing enormously, and therefore, let's say, we need some tools. And as Maris ourselves, we have developed a new tool called Beacon over the last year in a couple of European projects, and it's very promising. And we are now at the stage that we have a better version, which can be also tested out by other people. And I want to tell you a little bit more about that tool. It's in fact it's really a data lake solution. So it means that you have, let's say, you have a lot of data, a lot of netCDF files. You can easily load them into this Beacon tool. And the tool then makes an index. It keeps the files as they are, but it makes an index. And it takes a few hours if you have a couple of million netCDF files. And from that moment on, you can ask simply questions like, indeed, give me all the temperature at 500 meters for 2010. And then you get, within a few seconds, you get the answer from all those millions of files. It's a subsetter. And the reason why it's so fast, it has been developed in Roost, which is a quite powerful language, and it's also very close, let's say, on the operating system. And the funny thing, it doesn't use a database, but it keeps the data files, let's say, as they are, but it makes an index that it knows what's in each of the files, because it recognizes, of course, the container model, and this way it can operate very fast. And there is a link here underneath https beacon.maris.nl. At that website, you will find more information about this beacon. And also you can, if you want, and you have an interesting organization, you can apply that you are a beta tester for us to see how it works. Right now, we are already get a lot of interest. We have Argo as let's say as interested. We have Marine Institute. We have EMODnet Physics. We have several organizations already who are interested, say, to work with this beacon, simply because they were a little bit flabbergasted by the performance that we demonstrated to them. And I give you here some examples. We took, for instance, all the CDataNet data records, which are in the data cache. It's about 2.5 million data sets, which have 4 billion data points. Normally speaking, it's 200 gigabytes of NetCDF files. And we asked the question, say, give us the data from the longitude and latitude, a certain lat long box, a depth from 0 to 50, and a time frame of 2 years. And give me all the temperature parameters that you can find. And what you can see on the right is, in fact, the performance, and also what the time was spent, let's say, because there is, let's say, you have to read it, you have to harmonize it, you have to filter it, and you have to write the output. And in the end, if we take the whole collection of 2.5 million, you see that it only takes 2.5 seconds to get the answer. And the answer is, in fact, a homogeneous NetCDF files, which contains all the data sets, in this case, 12 million points. And this is not something, a sales talk, but you can see it yourself if you look at that website that I showed you. There are a couple of examples that you can operate yourself in a viewer, and you see really how fast it is. It's amazing. This is another example. We took, for instance, the whole Argo collection that Thierry showed on the Amazon service. And we did, in fact, also we developed a new viewer, and the viewer is also using new technology, also Roost. And it means that if you take 2.5 seconds to get the data, it takes another 2 seconds to draw this map, which is, again, is if you know normally how much time such processes take, it's quite an improvement. And quite a promising improvement, let's say, that we can use. And that's why for this data lake, we are now focusing on this beacon tool to make it more, let's say, more robust. And also to do some tests with our colleagues that they deploy it at their own place, which is also very easy. Raoul was telling about AirDAP, that this takes also just a Docker container, and you can start almost. You can start reading your files. It also runs even on your notebook very fast. You don't need a big computer, of course, but if you have a big computer, it goes even faster. So it's a very interesting development. I want to show you this other link here, this eosfuture.maris.nl, because that's a project we did recently for EOS Future, and it has a dashboard. And in the dashboard, let's say we are resolving both Argo floats as well as CDataNet data. And you can see how fast it then, let's say, retrieves the data sets, which are the actual values of the data sets. It's not the location, but it's the actual values. For us, let's say, in the Blue Cloud, we want to work in this way. That's in fact the way forward. That we have on the left the individual research infrastructure, blue data infrastructures. Then we have this data discovery and access service, which is like angling. And then on top of that, let's say, we gonna put the beacon implementations to build specific data lakes. Could be, let's say, for temperature salinity, it could be for eutrophication, etc. And in fact, these data lakes then allow you to do queries, and those queries deliver then homogeneous files, which can then immediately be used, let's say, for further applications. And in the case of Blue Cloud, the applications are workbenches, so-called workbenches, let's say, to work with to produce essential ocean variables for certain selected data sets. So there's more to come. If you want to follow us, there is a number of deliverables. All the deliverables are open and they're full of information. And so far, interesting ones for you are available at, let's say, 2.1, which is a little bit a review and the specifications of what we are going to do to improve the data discovery and access service with the individual, also the task for the individual PDIs. Another one is, let's say, a new report 2.2, which describes, let's say, the 4 new BDIs that will join us, and the ways that we think what kind of service they are offering and how we can make use of those, let's say, to fit them into the model. Later, there will be more deliverables, but they are not yet ready. And but when they become ready, of course, they will be available at the Blue Cloud website and also at Zenodo, so that you can follow it and make use of this for your own knowledge and developments. Okay, this is the end of this presentation. I hope that in fact the whole day we gave you a lot of information, a lot of food for thought, I think. And also, I hope that you understand there's much more going on under the hood than you ever thought about when you, because there's a lot of developments and also new uptake. So we have now 15 minutes left, and those 15 minutes, let's say, we can have some discussion and questions. And I hope that some people now will come forward with some questions or some discussions, because we gave you a lot of information, and it would be nice to see if you have certain interest or certain specific questions that we try to answer. But if you understand, the Blue Cloud is a running train. Let's say we are now 11 months underway. We have 3 years to go. And that means that in the project, we do a lot with, we have very large infrastructure. We have a lot of computing available to us and storage. Also, we have very excellent technicians and researchers, both, that want to use all the instruments. And we have some certain tasks, but it's an ongoing, I would say, interaction with the Blue Data infrastructures, because they also have ability in the project. They have funding and they have technicians, let's say, to make things more fit. So in the end, we have a more coherent landscape, and everybody has its own win-win situation. So somebody has a question from the audience?
There is one link on the question and answers chat from Kaori.
Yeah, maybe you can give him the microphone.
Okay. In a second. Hi, Kaori. If you wish, you are allowed to speak now.
Hello. Yeah, I already commented in that chat, but I was wondering about the AI. You already mentioned that it will be replaced by this federated AI for EOSC, right? But before that, I already asked about the AI federation. I don't know, currently this Marine Federation, Euro Federation, by D4 Science, managed for all the infrastructures. And then if that's the case, single sign-on to access all federated data from whichever infrastructure you log in, or is it centralized from Blue Cloud?
In fact, we make use of the EOSC Federation, or also it's also called EDI check-in. And that means that already thousands of university systems, etc., let's say, they are part of that federation. And it means that people that have already credentials in their system, they can walk through. Only the first time they have to, of course, commit themselves, let's say, to the policy or the license that is being asked from them, that they agree, and then they become a Blue Cloud user. But from that moment on, they can use all the time the same credentials and having access to the Blue Cloud facilities. And as I said, what we are going to do is make the data discovery access, let's say, also using the same mechanism, so that you don't need different AI systems or different credentials in that case. And this EOSC Federation, let's say, is being pushed, I would say, by the EOSC developments. And EDI is a major partner in those EOSC developments. So that's why EDI check-in. But it's also something is easy that for people to pick up. Let's say, if you have your own AI, for instance, Keycloak is a good deployment. You can make your own AI system, but Keycloak is really, it takes a few days to make it part of that EI of this federation. And that's in a technical sense, but you also need a legal sense. You have to, you must have a policy, you must have a license, you have to do some textual things, let's say, to make sure that you are a trustworthy operator, let's say, to become part of that federation.
Thank you for clarification. So you showed us that, this demonstration. Okay, when I log into Blue Cloud, then I see all the data sets available from other federated data infrastructures. Is it the same case if I log into EMSO or Argo CDataNet?
No, let's say federation is federation. So we are, let's say, on top of them. So we are in fact using the metadata from that we are harvesting from the different systems like Argo, like EMSO. Right now, EMSO is not yet connected in our system, but will be, let's say, in the coming months. But let's say, and we then allow you, let's say, also through this federation to drill down to data sets that you would like to have, and then to ask for those data sets, and they come then from the resources as managed by the individual Blue data infrastructures. But it's a common way, let's say, to have a common access to all those different services, which have each of them have their own interfaces, and we just built a common one. But of course, this is next to what they do themselves, because they have also other users, and it's not the idea to take over, but it's more a service, an additional service that we are offering. And in the Blue Cloud, it has a function in the sense that we have a lot of virtual labs, we have workbenches, and the users of those, let's say, they are in need of data from various resources, and they ask then the data discovery access service to prepare for them the data sets so that they can easily have a pool of data from all those different sites. And that's the function in the Blue Cloud landscape.
Yes, but according to this, I just want to end that, for example, if you are accessing to the Blue Cloud infrastructure with your credentials of your university, then with these credentials, you can also access at least to EMSO, because we are using the same system. Okay, yeah. I don't know if, so it's still not connected both, but the credentials are the same because both we are using EGI chicken. I don't know if it helps you to clarify this question, but.
Yeah, because let's say EOS is striving for a single sign-on, in fact, for all the researchers in Europe, that they can use one credential to have access to many different doors. And the only thing they have to do is first knock on the door, say, I want to get in, then they can use the key, but they always have to say, yes, I agree with your license, in fact, that and your policy. And if you do that, then from that moment on, your key fits and opens the door. So it's quite an important element of the EOSC development. Any more questions from people? Because we have still 8 minutes in our schedule.
So far, no, Dick. No further. Oh, there is one hand raise. Yeah. I'm going to give Piotr permission to talk.
Yeah, Piotr, go ahead.
Hi. Actually, the beacon is looks like a nice tool on top of all of these SDKs that we are seeing emerging in many platforms. And first, I wanted to ask if the repository is open, because the links doesn't work for the moment, so maybe that's an issue. But probably you have it in the repository. But I've seen that you are doing already some conversions, like at least in the examples, you have the unit conversions. So I wonder if that's done also to implement this kind of transformations on the fly on this data. And the other question is, how does it fit the other SDKs, like the Earth tools or EMODnet editor tools to access the data? Is it something that's going to be work together? And the other question is about this. About the processing and the outcomes of the processing. So are they also publishable? Like if I'm doing my own research, or if anybody else is doing some tool sets, can then deploy them also on this platform? And can they publish the results somehow? Or is there a plan for that?
Now you have a lot of questions. Now to start, let's say with Beacon. Beacon is, like I said, we have a beta version. It's we just opened this website, and if you have a problem in reaching it, I have to talk to my colleagues because it should be open. But what you the tool itself, let's say we have a registration list. So we'd like to, if you are interested, you have to register yourself and give us a little bit an example of how you want to use it as a beta tester. And based on that, we can provide you that tool. There is a GitHub attached to it, let's say, which tells you more about the documentation of the tool and what it can do right now. And our idea is a little bit to develop it further as say that we keep control of the kernel, but that everybody can make their own plugins, let's say, to the in and out, and this way it can work as a little bit as an open project. The second thing is that the Blue Cloud itself, let's say in the Blue Cloud we have the virtual research environment, and that environment is in principle also open. So if you are interested, let's say, in making use of facilities and the virtual labs, which are already, let's say, if they are open already, let's say, you can apply again with a little bit motivation, and then we can see how we can help you to make use of those facilities to do open science and also let's say help us to spread the uptake of that platform and the facilities that we have, because it's say Blue Cloud is really an organic project in that sense, that we have a lot of capacity, a lot of resources, but we like to spread it, not keep it only for the consortium, but we really want other research groups to come in and make use of it and then demonstrate the added value, of course, for ocean health, because ocean health, let's say, that's our domain. And so we want to stick in that domain, but it's but that's how it could work.
Okay, thank you.
Yeah,
that's okay. So
another thing for the moment is Beacon. Like I say, Beacon is interesting for us as in part of the pipeline. It's also interesting for individual RIs, and some of them are already looking into this, and because they, like also Raoul was explaining a little bit EMSO, let's say. They have a performance issue if you leave it all to AirDAP. AirDAP is a very good communicator, but it's not a very good data cruncher with big data sets. And Beacon could be you can also do OpenDAP, of course, and other applications which are already there. But we have the feeling that with Beacon we have quite we can be faster and and we are a step forward towards data lakes. And data lakes is something which is more and more important for the digital twin of the ocean developments, because there they want data lakes. And there are many ways to describe a data lake, but we think we found one of those definitions. Bring all your data together. Let's say simply don't do anything with it, but index it and make it accessible by slicing, without having to load it first all in a database, which is normally done. We always are transforming. But in this case, you don't have to transform. That's the trick, in fact, and that's also the beauty of that solution. Anybody else? Maybe the colleagues, Raoul or Thierry, you want to say something about in general as a last words?
Well, no, in the case of EMSO, for example, we want to use the beacon. When you have the stable version, for sure, we will be one of your users, because I think it's a great tool. And of course, if it's easy to put in our place, I don't know how exactly now, because I didn't work with this. But for sure, we will try to use and join efforts with you.
Okay, Thierry?
Yes, just a word on Beacon. Beacon is more than promising. It's already delivering data access that allows interactive interactions with huge amount of data with response time within something like most often less than 1 second. It's in the category of the ARCO formats, the analysis really cloud optimized, and it's an excellent examples. And it comes along other ARCO formats such as Parquet, such as ZAR, and so in the Blue Cloud, we have to be really adopting experts on these technologies.
Exactly, and that's also the function of the Blue Cloud. It's partly as a development laboratory, but with a very practical direction. Let's say we we're also working together with another project, FAIRness, that's going even more in experimental. And FAIRness is the laboratory for Blue Cloud. So it's a little bit how we set it up. So they try all kinds of concepts. If something is promising, then we move it to Blue Cloud, and in Blue Cloud we try to make it more, deploy it and make it part of the pipelines, let's say. And that works very nicely because it brings together a lot of expertise, both in science as well as data management, as well as in technology, which is underpinning those services that we need. And then we are also lucky that we have this platform with sufficient power, let's say, in CPUs, GPUs, storage, etc., to be able to let's say, to have a very nice playground to try out all these things, but also to make them operational. That's also important, of course. It's not just playing, but also business. Okay, hey, then maybe it's now time. It's 12 o'clock, so I hope that you enjoyed our presentations.
I think so. Okay.
Okay, so I hope that you had a very good time with this, what we presented you. All the presentations will be available. It was also in the chat.
They are already available at the moment, the PowerPoint presentations. The recording will be available by mid-afternoon.
Yeah, okay, very good. And of course, we have the list of people that registered, and we will inform them, let's say, by an email about where they can find the further information. And as I say, if you have further information or questions, of course, you know how to reach us, and then we can see how we can answer. But thank you very much. This was, by the way, a webinar we organized together as Blue Cloud, and also the Ocean Best Practices service that is being run by UNESCO IRDE. It's a co-production, and there will be more of these webinars coming. Let's say other topics, and so keep your eyes open also on the website from Blue Cloud, and also from OBPS to see what's coming next, because we hope that we can give you all the time some very interesting state-of-the-art presentations, and keep you, of course, informed about the progress of the work that we are doing. Thank you very much for your attention.